So we're back at it again with this placement object system tutorial thing. And in this video, following off the previous, we added serialization. Make sure to watch that if you didn't. But now we're going to deal with just some basic like laundry list items of just things to get done. So first of all, we can rotate objects now. We can delete objects. And then we can also cycle to different objects. So this basically, in this video, you'll take everything that you like the proof of concept that you had in the previous video and turn it into an actual workable system that you can use for a game or for anything that you want. So I hope you are excited for that. Make sure to like the video if this is good, if you like it. Subscribe to my channel for more videos, comment any questions or suggestions, and also join my Discord server. I usually don't say that, but I'll say it now. And also, I'm a little bit under the weather. Well, you can probably hear I sound like crap, but don't worry, the video still gets done. But I sound weird, but I'm fine. Like it's chill. But yeah. So without further ado, let's get into the video. So as you start on our laundry list of things to add to our plot system to make it, a little bit more usable, let's add rotation. So the ability to press a key and rotate our object by like 90 degrees. So to start out with, we're going to go to the new method or new function here where we set our plot, we set our preview, and we're going to create a new value and call this rotation. We're going to set rotation equal to 0. So what we're going to do is every single frame, we're going to alter the preview's appearance by this rotation. So let's actually do that. So down in our render preview, we have this cf equals cframe.new cast.position. Well, now we need to multiply this by cframe.angles 0 self.rotation 0. So what this will do is it'll rotate the Y. So by the way, rotation, I mean just like Y rotation. So that just means like rotating around its base. And you'll see what that means in a second. If you want to add other rotations, you can, but this is just the most used rotation that people use for like furniture and stuff. So we just basically multiply this every single frame. And since this is constant, this is not like dependent on these, this will like output the same thing like pretty often. So always. So what will happen is this CF is just generated based off the position plus the rotation, which is exactly what we want. But obviously we need a method to actually rotate it. So and right below our try place block, we're going to create a function, client placer, rotate block, and this will take in just whatever, the state, and whatever. We're using the underscores again just to say we don't care about that parameter. And then we're going to do if input state, or if state equals enum.user input state.begin, then we're going to do self.rotation plus equals math.py. So we're using math.py here. Oh, actually math.py divided by 2. So the reason we're doing pi, if you're kind of confused, because like rotation, I thought it was like value 0 to 360. We're using radians. So when we do C-frame angles, this takes in a value of radians. Radians go from 0 to 2 pi. So pi over 2 is just equal to 90 degrees. So this is the same thing as saying 90 degrees. And we don't have to like loop it back around. You may be thinking, oh, like why don't we go back to 0 after we do like 4 rotations? It's because if you rotate an object by like 3 pi over, no, what is it? It would be like 5 pi over 2 or something. Like it'll loop back around to where it would be when you would like reduce it. So we could just like increment it infinitely, which is pretty cool. I mean, I guess if you do it too much, like you could lead to like a float overflow, but like that is way, way out of the scope of this video. So this should work just fine. So now we have to actually bind it because we can't use it if it's not bound. So we can just copy this bind action verbatim here. I apologize, I'm a little sick, but the video still gets made. So we're gonna do a local rotate action, and this will be equal to just rotate whatever. We're defining the constant just so we don't make typos and we get autocomplete. So we're going to bind action, rotate action. It's going to be a blank function where we pass in the arguments into self.rotate. block, and then we pass in the arguments, and then we end it, and then we do false. We don't want a touch button, and then we're gonna do enum.keycode.r. So it's just gonna rotate around. You could do one for forward, one for backwards, like for the plus and minus, but this is easy. It should be fine. So that should be the entirety of rotation done. But before we forget, remember we bind action. We also have to unbind action. Whenever you bind an action, you always want to remember to unbind it. So I almost forgot actually. So we're gonna do context action service unbind action, rotate action. So again, and destroy. Whenever we destroy our client placer, we need to get rid of all of those keybinds. That's what we're doing here. So let's play this. And now if we bring up our part and we can like place a couple and we press R, it rotates. Cool. And since we are dealing with a table, it only has like 2 rotations that it looks like. But for like chairs and stuff, like, you'll be able to see all the rotations. So rotation works pretty well. Okay, next step. Oh, also, by the way, if you're running into issues, it could be because you got to make sure the studio access to API services is on, especially if you're using the last video, because the plot manager won't work. It'll just bail out early. So just remember that. Okay, and now next, let's do deletion. So object deletion involves some server code. So let's actually start with that, and let's go down the tree in the client. So let's go into the plot manager, and we have a place function. Let's add a delete function. So let's do function plot manager dot delete. We do player, which is the player, and then object, which is the instance. Yeah, I guess instance is probably no. I guess it would always be a base part. But we have object, which is a part. I'm gonna assume it's a part because the way we're gonna get this on the client is by raycasting. So we're gonna return a boolean whether or not it's successful. So first of all, we have to get the plot. So local plot equals plots player dot user ID. So there we go. We got the plot. And so now we have to check if not plot. So if the player doesn't have a plot, or not object, or, and we're gonna put this one on a new line. Oh, well, it created that. So or not object, and then we're gonna create another or. So or, and then or not object is descendant of plot.objects. Then we're going to return false. So this is our guard clause or early return conditions. So obviously, if there's some malicious actor who doesn't set an object, we're just going to bail out. If they don't have a plot, obviously they can't delete anything. And then if the object they send is not a part of the plot objects, they shouldn't be able to delete it either. So now we have to delete the object. So you may be thinking, okay, let's just do object delete, right? But remember, our objects, our placeable objects, it's a model with parts. And also, sometimes when you have parts, you may also have folders, other submodels within the model. So I want to find this top level table model without like deleting something underneath it. So for example, if table has a model in it called legs, I don't want to delete legs because like you could just do, okay, find first ancestor, which is a model, and then do that. That would not work for all cases. So we're trying to make this as ubiquitous as possible. So your designers or whoever's working on your objects can just like plug and play and not have to worry about a specific format. So the way we're going to do that is using a quick little algorithm to search up the ancestors to find the object model. So we're going to say local actual object equals object. So this is our starting condition. We're going to say while actual object dot parent is not equal to plot dot objects do. And then each time we iterate through this, we're going to say actual objects equal to, or actual object equal to actual object find first ancestor, which is a model. So what this will do is we'll go through. So let's say we start at this part here at the table. It'll say, okay, part equals actual objects. So part.parent is equal to table, which is not objects. And then we'll say, okay, actual objects equals actual object, find first ancestor, which is a model. It'll go up to the model level and then go from there. Now you could obviously just set actual object equal to actual object.parent, which that would get the same thing done. It's just this was probably a little bit quicker because I'm assuming find first ancestor is optimized, also probably written in C++, not Lua. So this will be a little bit quicker than just manually traversing the entire tree, so we can jump because we know the top level model has to be a model, or at least in my implementation, we're assuming that the very top level placeable object is a model. If you want this to be a folder, if you want this to be whatever, then you would just do actual object of parent. But this is how it should work. So this should guarantee that if it's a descendant of plot.objects, you will get it. And this would actually work maybe if you just have a single part, which is a placeable object, because it would check actual object dot parent is not equal to plot objects, and that should work. So it should theoretically work for most things. So now all we have to do is do actual object destroy. But just remember, if you run into issues with your destroying or deleting functionality, and it's like not deleting the entire model, make sure this group is correct. This group of lines. And then obviously after we destroy it, we return true saying, okay, this is successful. But this doesn't go to anything. So let's go create a new remote function in replicated storage. And this remote function is going to be called try delete, as following the naming convention of everything else. And then we're going to go into a server, and right below we do like the on server invoke stuff for try place. We're going to do try delete. But first we have to get it. So local try delete equals replicated storage dot try delete. There we go. So then we're going to do try delete dot on server invoke equals plot manager dot delete. So, and then autocomplete is beautiful. That's great. Okay, so now this is hooked up on the server side. All of the wiring is in place. Let's go to the client. And first of all, we have to get that remote event. So we get try place here. Let's just, honestly, we can just copy paste try place. That would honestly work. So we got try place. Well, now this is try delete. And then instead of replicated storage wait for child try place, we're going to do replicated storage wait for child try delete. There you go. So now we have our try delete. And what we have to do next is go make our delete object function or method, I guess, since we're in a class, right below our try, or right below our rotate block. So we can just do function client placer delete, or I guess we do try delete block, keeping in convention with everything else. I'm going to take just the name, we don't care about that, the state, and the object also don't care about that. So now we do if state equals enum.user input state.begin, then we want to do local cast equals cast mouse, and then if cast and cast.instance, then we want to say local success equals try delete invoke server cast.instance. Okay. So what we're doing here is basically it's a standard input like collection thing, and we get the cast. Obviously, we defined this function earlier, cast mouse. If you don't remember, it just does a simple recast, simple wrapper, and then we make sure that the thing it returns is actually there. Now, our function, our try delete, could actually handle a nil instance, but since we don't want to like send data to the server unnecessarily, there's no point. We might as well check it on the client. So now, and then after that, we get this try delete. So we're getting success. We're not going to do anything with this, but the reason this is a remote function is so that the client can have some feedback to the user when they delete something and it doesn't work. Like pop a little message, say like delete was unsuccessful or something, just to let them know. For my purposes, I don't really care since this is just a little demo, but it's here if you want it. So you can say, okay, if success, then we maybe change a color or like add some sound or something. Or if it's a failure, we like you add like a sound, like stuff like that. So you could do that if you want, and just remember it's there for you to do that. Okay, so you know the routine. We're gonna go up to the top. We're gonna do context action service. No, that is continue, not context action. Bind action, and then we need to get the delete action. So we're saying local delete action equals delete. And we're going to do delete action, and then we're going to send in the function self delete try delete block. There we go. And false enum.keycode.x. Now, so I'm using X to actually delete the blocks. So most other games, or at least a lot of the ones I see, actually don't do this style of deletion. Most games just kind of do like, oh, okay, switch to delete mode, and you're able to click on a bunch of things. I initially toyed with doing that for this series, but if I'm being completely honest, it Like, it's a lot it makes things a lot messier because you have to deal with a lot more state and handle a lot more state transitions, and that's just out of the scope, out of this, like, little framework we have set up for Client Placer. But for the way we have it set up now, this actually works really well, and you can see the power of this kind of framework where we have just a single class with all the stuff that gets, created and then destroyed at the end of each, you know, bit when you press B to, like, enable or disable it. It makes adding new features really, really, really simple because all you do is just add the function, bind it, and then unbind it. That's literally it. So, obviously, we need to do unbind at the end. We're gonna do delete action. There we go. So, this should actually work just fine, I think. Should be working. Let us see. So, we have our stuff. There's a lot of tables here. I press X, it's gone. It's gone. And then since we just delete it, actually, the saving system should work just fine around that. So you're able to delete stuff, you're able to add stuff. Yeah, it all works perfectly fine. Okay, finally, well, yeah, finally, we can get to cycling objects. So cycling objects, by that I mean like switching from one object to another. And we're just gonna add that as like a simple EQ, like key binding. So let's first create another object. So I'm gonna create a quick little table. Actually, no, we can make a chair. It's gonna look really bad. You're not gonna judge, but it's gonna exist and it's gonna be beautiful and it's gonna be a great demo. So we have our table, or this is a chair. So this is our chair. It's a very sad chair. It takes a lot of L's if you get what I mean. So we're gonna make sure the pivot's on the bottom. Probably should have done this before the video, but whatever. And we're gonna make sure everything's anchored. Okay, cool. So now we can move this chair into our placeable objects just as a demo. Okay, so now let's go to our client placer and we need to go and create a function, another function. Again, the same method. So if you want to add more features past what I'm showing you today, like maybe a grid or something, then you can just add another method, and it'll get the job done and just bind it and that'll be it. So we do client placer cycle object. This will take in a state with the underscores as always, and if state equals enum.user input state to begin, yada 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 yada. You guys have seen this 100 times. First of all, we're gonna get objects. We're gonna say local objects equals placeable objects get children. So we're gonna get all the children. This will return an array of the objects that we can place. So we're gonna say local direction equals if object dot keycode equals enum.keycode.e, then 1, else -1. So this if then else expression, oh, we actually have to use the object, crap. So up here in state, and then after state, we're going to put a object, which is the input object, which is where we get the key code. Sorry, a little misunderstanding on my part. But we use this if else expression to say, okay, if they press E, then they get 1. If they press Q, they'll get -1. So it'll kind of tell them which direction, or it'll tell our script, it won't tell them which direction the cycle should go, like which next object we should choose. But right now, we actually need to figure out like what the index should be. So we have a preview, right? But we need to keep track of a preview index. So we're going to say preview index, and this is back at the top in the next block. Preview index will be equal to 1, or not in the next block, in the new block. So we set preview index equal to 1. And so now when we prepare the preview, initiate render preview, we prepare preview model. We want to actually do placeable objects get children 1, or self.preview index. So this is a better way of writing our initiate render preview, and it'll always give you one. I mean, I'll always give you the first one. So in our case, it would probably be the table. It might be the chair since it's alphabetically higher. I don't really know how it's organized, how the children are organized when it's returned, but it'll give you the same thing every single time. And so now, when we want to actually augment that preview index, we can. So right below, we get the direction. We can say self.preview index equals self.preview index -1 less direction, and then after the parentheses, we can do mod, or like %, the number of objects plus 1. Now this is like This is wacky, bro. Like what is going on here? This took me some trial error to get. Like I didn't just like say, okay, like we're gonna do this, we're gonna write this. It also doesn't help that Lua is one based, like one index based. This made this a little bit more convoluted. But basically, what this does is when we have the preview index and we add the direction. But if the direction overflows, so like let's say we have two objects and the index goes to 3, we want it to wrap back around to 1. So what this does is we basically say, okay, we take the preview. So let's actually take that case. So it's 3. So the value is 3, but we only have 2 objects. So it's 3 minus or so self.preview index would be 2 in this case. So it'd be 2 minus 1, which is 1, plus direction, which would be 2. And then we do mod objects, number of objects, which is 2. So this would go back to 0 plus 1, which would be 1. So if we're at preview index 2 and our direction is 1, so our target preview index is 3, then it'll wrap back around to 1. And that's exactly what we want. So now we can after we calculate the new preview index, we can just say self prepare preview model with objects and then we can just self dot preview index. So we just call the prepare preview model, and you remember when we wrote prepare preview model, we made it so it would destroy the previous preview. So that just does it on its own, and it sets it all up nice and prettily. And that's really all we need. Now, I think, like, now that thinking about it, you might run into issues with the get children because get children I'm not sure if it's deterministic on what it returns, like the order of children. So you may need to manually define a list of the placeable objects to cycle through. But for my cases and my testing, this has worked just fine. But just be aware of that. I think it should work though. So now we just have to now we have to go through the steps of binding it. So again, nothing new here. Context action service, bind action. Then we need to do cycle action. Cycle action. Cycle. There we go. Cycle action. Function. Dot dot dot. So cycle object. Dot dot dot. And false. And then enum.keycode.e. Enum.keycode.q. So remember to put both e and q in the list of the keys that we send, so they can both be used. And then we need to remember to unbind it, of course. Text action service, unbind action, cycle action. There we go. Okay, so let's test this out. Should work literally just fine. Like there's nothing special here. So we have our object. It's our chair. This chair looks really dumb. And then we can press E, cycle it. Press E, cycle it. Boom, boom, boom. Press E. Right now, since there's only 2 objects, E and Q doesn't really do anything different. But trust me, I tested this with 3 objects. It does work. So we can have, so now using everything that we created, so we can first delete this because I put it in the wrong spot. So we have this table here, create a chair here, rotate this around, create another chair. And then using all the stuff that we implemented today, we can actually create a nice little dinner setup. There we go. So that's great. So now we have our little table, our chair, and everything works fine. You're able to delete, rotate, and do other stuff. So I think with that, this formally ends the placement object system series. Now, if you want to see a grid, I can do a quick little video on that. I mean, it's pretty easy to implement. Like it's just getting a grid function. Find like go on scripting help or something, you can find that. But I really hope you enjoyed this series. Let me know if you have any more suggestions for future videos that I could add to it. But I think right now this is probably all I'm gonna do, depending on what suggestions I get. But I really hope you enjoyed it. Let me know of any future series you want to make or you want me to make. And any questions. So like the video if you enjoyed it. Make sure to subscribe for future videos. And hopefully I'll have a little bit more time very soon to make a little bit more videos. But I don't know. I don't know about that. No promises. And with that, I hope you have a nice day and goodbye.